Okay, so this is part 2 of 7.2. Washer method. Washer method, we're still going to do the disk method. The difference is that there's a hole. There's literally a hole in the middle of our figure. So what are we gonna do? Washer method. So we're gonna do the bigger radius minus the smallest radius. Okay. So pretty much we're subtracting the whole. We're taking away what we don't need. It's kind of like creating a bowl. There's a bowl you're creating. So right here, this is exactly what I was saying. So we have the upper function. Oh, this is our first example. And I continue with example 4 because we left off example 3 with the first part. So look at this example. We have y equals the square root of x as one of our functions, and y equals x squared as my other function. It says find the volume of the solid form by revolving the region bounded by the graph y equals square root of x and y equals x squared about the x-axis. So we are rotating it about the x-axis. I'm going to do a little sketch of the graph just like we have it here. We're rotating it on the x-axis, so it's going to be in terms of dx. It's very important that we know where they intersect. Okay. So this is what we're looking at. The function on the top is the square root of x. The function on the bottom is x squared. Okay. So we're rotating it on the x-axis. So what we're going to do, I'm going to get the bigger radius, which is this one right here. Remember that we have our pi. Pi doesn't change. Pi is still there. Pi doesn't go away. So we have our pi. And we have our integral. And it goes from 0 to 1. That will be our limits, our boundaries from 0 to 1. In this case, from here to here is my bigger radius. So I'm going to have the square root of x squared minus, okay, we're going to take away, because if I rotate all of that, I'm going to get, if I rotate that one, I rotate it this way, I'm going to get a solid. But I want to do a hole, so this is the other part of it. I want to take this middle part away. So what we're going to do, we're going to subtract the smaller radius. I want to take away this radius right here, because that creates the hole. And the smaller radius in this case will be x squared, and we square it. And we have our dx. Okay, so let's simplify. So we have pi from 0 to 1. Square root square cancels. Square to the square, we multiply the powers, and they give me a power of 4. Let's do the integral. So in this case, we have pi x to the power of 2 over 2 minus x to the power of 5 over 5. And we need to evaluate it from 0 to 1. Again, we need to plug in first the 1. So we have 1 squared over 2 minus 1/5. And then this one minus 0 squared over 2 minus 0 to the 5th over 5. Again, just like the other one, we have a 0. This goes to 0. I don't really need it. So we need to simplify 1/2 minus 1/5. Okay. Common denominator will be 10. So we have 5 over 10, because I'm multiplying this one by 5, this one by 2, 2, and that gives me 10. And that will be my answer. Okay, my next example has actually 3 parts. So example 5. It says, find the volume of a solid form by revolving the region bounded by the graph y equals the square root of x, y equals 0, and x equals 3. y equals 0 is the same thing as the x-axis. Okay, so how does this look like? Again, you guys have a powerful tool that we can use. So I went to my Desmos and I graphed these two. Remember that I can even type a y equals 0. Y equals 0 would just be, again, this x-axis. So this is the area of rotation. And the first one, letter A, says we're rotating it on the x-axis. I just drew the figure again. So rotating it on the x-axis, there's no hole. In this case, is the disk method, where we have this, the function as my radius. So from here, don't forget your pi. Your boundaries would be from 0 to 3. So from 0 to 3. My radius is a function, which is the square root of x. We need to square the function, dx. So then we have x dx. To evaluate it, we square it and divide by 2. Don't forget that we have pi from 0 to 3. Okay, so then we have pi 3 squared over 2 minus 0 squared over 2. So we have pi 9 over 2. And this is when we're rotating it on the x-axis. Next one is rotating it on the y-axis. So rotating it on the y-axis, we still need the same region. So this is the radius that we need, okay? This is the area, the radius that we're going to be rotating. And then we're going to be rotating it this way. Oh, and this one I forgot to do it. I like doing it. So I like doing my dots down here. And this is where it's going to be rotating it. This one, this is my line. It's going to be kind of like that. And we're going to be rotating it this way on the y-axis. So we're going to be doing it. Don't forget y. What will be our values? Here, the point is 0, 0. Here, the x value is 3. To find the y value, we plug it into the function, and we get that the corresponding y value is the square root of 3. So my limits would be from 0 to square root of 3, because now I'm going from the bottom up. I'm looking at y. You're looking at y. So now, look at this. This is the washer method. How do I know it's a washer method? There's a bigger radius. And my bigger radius is from here all the way here. And that's a constant radius. The radius is just 3. Okay? So in this case, it's going to be 3 squared, which is the bigger radius. Bigger radius. Minus the smaller radius. So it would be 3 squared minus this radius right here. This little portion right there. We want to subtract the portion. So to subtract the portion, that will be the function itself. Okay? So it will be the function, but it needs to be in terms of y. I was going to put square root of x, but now it needs to be in terms of y. So we have y equals the square root of x. We need to solve for y. So we need to square it. So we have y squared equals x. So here, we're going to have y squared squared. And then we have our dy. So in this case, let me rewrite it down here. We have from 0 to square root of 3, 9 minus y to the 4th dy. And that's what we need to integrate. Okay, so in this case, we have 9y minus y to the 5th over 5 from 0 to square root of. Okay, we're going to have a square root, but that's okay. You leave the square root. Do not try to simplify it. So we're going to have 5, 9, square root of 3, minus, we have square root of 3 to the 5th power over 5, minus 0. Remember, when I plug in 0, that's just going to go to 0. So I really don't need it, because it's going to go to 0. So here, the only thing that we can simplify is this right here. And we can write it as 9 square root of 3, just square root of 3. I can write the 3, and the exponent will be 5/3 over 5. Okay? You can leave your answer like this, or you can put it like this. Unless the problem asks you as a decimal, then you'll need to put it in the calculator and write it as a decimal. It just depends on how the computer or WebAssign wants you to plug in the answer. Okay? Letter C is rotating it on x equals 8. It's rotating it on x equals 8. So let me show you how that looks like. I like drawing it again. And we're rotating it this way. So it needs to be in terms of y. We had already solved for x, so we're going to be using this function because it's rotating it this way. Okay, so again, we're going to do the bigger radius minus the smaller radius. Okay, I know it sounds super like, what in the world we're going to be doing? That's okay. We're going to take it by parts. So I like talking about the bigger radius minus the smaller radius. Okay, so what we do, remember, we're rotating it this way. So we're going to be doing from here, the bigger radius from here to here. Okay, that will be my bigger radius, right? My big radius. Okay, don't forget the pi. The height is the same. It will be from 0 to the square root of 3. We're going to break it down. First, I'm going to get from here to here. What will be this radius? Okay, from here to here, remember that from here to here is 3. And I need to subtract this little part. So it's going to be 3 minus y squared. Okay, then from here to here, 8 minus 3 will be 5. So I'm going to be adding 5 more. That will be my bigger radius minus my small radius, which is going to be the whole. In this case, the whole is 5. It's going to be 5 squared, and this is in terms of y. So it's going to be dy. So let's simplify. 5 plus 3 will give me 8 minus y squared, 25. Okay, we need to distribute. It will be easier if we distribute this. Okay, 8 minus y squared, 8 minus y squared. So here I distributed the 8. 8 times 8, 64. 8 times negative y squared. Negative y squared times 8. Negative y squared times negative y squared becomes a positive y to the 4th. And then I'm just combining my terms. And now we do the integral. So we're going to do the integral. So it'll be 39 y minus 16 y cubed over 3 plus y to the 5th over 5, evaluating it from 0 to the square root of 3. So we just, again, the 0 is just going to go to 0. So we have 39 square root of 3 minus 16 square root of 3 to the 3rd power over 3 plus square root of 3 to the 5th power over 5. Again, it just depends on WebAssign how it wants the answer, but that will be our solution.